Carl Sagan once said, "On Titan, the molecules that have been raining down like manna from heaven for the last 4 billion years might still be there, largely unaltered, deep frozen, awaiting the chemists from Earth." Well, I think that the words of Carl Sagan in his book Pale Blue Dot are about to become reality. I'm Dave Farina, and welcome to the Cosmos Safari podcast. And with me is Rob Webb. Hey, Rob.
Hi, how's it going? I love how Carl Sagan just has a way with his words. He's always so poetic. It feels like he really takes time to really, make it good. I really appreciate whenever, I read his work.
He is my 100% my person that I look to for all of the things I'm trying to do with Cosmos Safari, hence the name Cosmos Safari. So I
Yeah.
felt it was appropriate to have a Carl Sagan quote for such an awesome mission. We're going to be talking today about the Dragonfly mission that is planned to go to Titan, which is a moon of Saturn.
Before we do that, before we dive in, I want to see how smart you are. Your ego is on the line here. First question: how many missions have been sent to Titan? Either a flyby or a lander.
So there was the Pioneer mission, there was the Voyager 1 mission, the Voyager 2 mission, and then Cassini-Huygens. So that's four missions that I'm aware of that have been in close proximity to Titan.
Yeah,
Okay.
that's it. You're wrong. I'm right. Okay. I've got I've got three. And it's Voyager 1, Voyager 2, and Cassini-Huygens. Okay. If Pioneer is there, we'll come back on here and I'll make a correction and I will say that I was wrong. But
Well, too bad. I already looked it up. Pioneer 11
yeah.
was the first spacecraft to study Saturn up close. Just looked it
No.
up.
Gosh darn it.
Yes.
I need to double check my work a little bit. Oh, yep, there we go. Pioneer 11. All right, well then it is four. That's right. Voyager 1, Voyager 2, Pioneer 11, and Cassini-Huygens. Very good. Very good. See, now you're
Does
up
not
1
hurt that
nothing.
I just researched all of this.
Nice. All right, question number 2. How do moons get their names?
Hmm. Is this a multiple choice or is this just
No, this is
a
not multiple
question?
choice. Just give me a quick like 2 sentence. What do you think? Like what's a general pattern?
Uh, it would be the International Astronomical Union, like Pluto was named with.
That's where we're at right now. Yeah. I was actually digging into how everything got their names, and the planets are mostly Roman mythology, mostly Roman.
Okay.
I could go into the whole thing, but I'm not going to do that. Except one, Uranus is the one Greek deity of the heavens, but every other planet is Roman. Now, the natural satellites, think about the Galilean moons, right? Those were all mythological characters. Those were in from the life of Zeus. And then other ones, if we find new ones, we actually have to give them a provisional name. And then, like you said, the International Astronomical Union has to basically write off on it. Although this one also said there's a it's assigned by the Central Bureau for Astronomical Telegrams. That's who gives them the temporary names. And really, the only other thing was that the moons of Uranus, they are a very special case. Do you know what the moons of Uranus are named after?
I do not.
Oh, literary characters from the works by William
Interesting.
Shakespeare. Yeah,
Ah, okay
yeah.
then.
All right. Okay, question 3. Who was Titan? Or what was Titan?
Hmm. I would have thought it was just the Titans from mythology. Am I wrong?
Bingo, bingo. You got it, man.
Okay.
I'm definitely giving you a point for that one. That's exactly where it came from. Named by the son of William Herschel, John Herschel. The Titans were the former gods, the generation of gods preceding the Olympians. They were overthrown as part of the Greek succession myth. And there was this whole like competition or something between them and all of that. So it's pretty interesting.
Was I just
Now,
3 for 3?
I guess you could call it 3 for 3.
I
That middle one
mean,
was kind of half, but I'll give it
all
to you.
right.
You're 3 for 3. Now, let's talk about why we're even doing this thing, right? Like, why are we going to Titan? What are we investigating in Titan? What makes Titan so special, right? That's where we're going to start off. Why are we even doing this mission, right? So, Titan is Saturn's largest moon. It's about the same size as Mercury. It's the second largest moon in the solar system, only to Ganymede. That one's a little bit bigger. And it's about 50% bigger than our moon. It's icy, it's got a golden hazy atmosphere, but that's not interesting yet. Here's the key: it is the only world besides Earth that has standing bodies of liquid, including rivers, lakes, seas, all that stuff on its surface. It is the sole other place in the solar system known to have an Earth-like cycle of fluids, raining from clouds, flowing across its surface, filling lakes and seas, and then evaporating back into the sky. It's basically the water cycle, but on a different planet, and it's not even water. It is methane and ethane, or methane and ethane if you're from across the pond. So Titan's atmosphere also happens to be 4 times denser than Earth's. Its gravity is about 1/7 of the Earth's, and this combination means that Titan's raindrops fall slower than the Earth's, like much slower. In fact, rainfall on Titan might actually be kind of rare. It might be centuries between showers at any given location. But wait, there's more, because Titan also might have a subsurface ocean of water, right? So we're talking about a place that has the water cycle, but with methane and ethane, right? So it's super cold there, right? It's nowhere near the temperatures we have. In fact, if water was on the surface, it would be rock hard, right? But then, because of the pressure, and I know you're going to get into this later, there could be liquid water under the surface, like that. That's huge, and that's huge because of life, right? There is a
Right.
potential for life on Titan, right? In fact, we first really figured this out when the Huygens probe measured radio signals there, and they found that there should be, they suggested that there might be an ocean 35 to 50 miles below the ground. And it could have some conditions suitable for life as we know it, right? With water, liquid water, or it could be life as we don't know it. It could be completely different. It could be life that processes methane and ethane the same way we process water, right?
Right.
So, and again, from Carl Sagan, he said this back in the day. He said, simulations suggest that building blocks of proteins and nucleic acids in the clouds, all of that is similar to primitive Earth. So we got to go
Yep.
there,
And
right?
this is an analog for primitive Earth that, as that quote we started with, um, does a good job, explaining. These are locked in, basically icy time, where we've got this little analog for what primitive Earth probably looked like. And, we're going to get our first chances to see what this looks like in the mid 2030s. So I'm super excited to see what this is going to look like. You've alluded to a few things. I'm going to back us up just a little bit with some of those other missions that did visit prior to the Cassini-Huygens. There was the Pioneer 11, as we already discussed. And then there were 2 Voyager missions that went past Saturn on their way out through the solar system. And all of them could get data, but they couldn't see the surface because the atmospheric gases were opaque to the sensors. They were unable to penetrate the cloud cover. And as a result, we got preliminary data, and we were able to make some, educated guesses based on that data, what was below the clouds. But it wasn't until the Hubble Space Telescope looked at uh, the moon in the near infrared and was able to penetrate the clouds, and they saw that there was variability in the surface, bright and dark regions. And as you said, then not until the Cassini-Huygens mission in 2004, and then the Huygens probe going down in 2005 to the surface, did we get an understanding of how different this particular moon was to anything else in the solar system, with the exception of Earth. And I find it fascinating how many years it took us, how many decades it took us to finally get to the point to confirm ideas that Carl Sagan and others of his era had, hypothesized. And, I think that the same thing is going to happen here with Dragonfly. We're going to get a confirmation of a lot of the things, and we're going to find a lot more that's new that we never expected, as science always does for us.
Oh yeah, I'm looking forward to seeing what questions we have after we do this, right? Like
Right.
what do we learn that confirms, and then where do we go from there? Absolutely. So what does it have going on in the atmosphere? Like what I mean, I know Titan's cool because it's got the water cycle, potential for life. Like this is the closest thing to a planet Earth, a second planet Earth, I would say, in our solar system in certain ways.
So
So what's going on inside?
I thought I would kind of take us on a little bit of a journey from the upper atmosphere down all the
Hmm.
way to what we believe the internal geologic layers look like as well. So, starting from the top, is a thin layer of haze. And that haze includes a lot of organic molecules um, that are basically interacting with the sun's ultraviolet rays through photochemical reactions, as well as the high energy particles that are being accelerated by Saturn's magnetic field. And those are producing um, this photochemical reaction where basically methane is broken down and it interacts with the nitrogen in the atmosphere to create a number of different organic molecules from that like methane feedstock, which is kind of interesting. And uh, as we continue to go down, we continue to hit various different levels of cloud cover. A thick photochemical haze is a little bit lower in the atmosphere, and that's the one that would be responsible for some particulate matter falling from above. And then if you go down even further, there's the methane and ethane, which would be the one that's responsible for like this methane and ethane cycle that's very similar and analogous to Earth's hydrologic water cycle. So, that's the kind of sequence as we go deeper and deeper into the atmosphere. Now, once we get to the surface is actually the rock is water ice, and it never really truly leaves its solid state, with the exception of volcanic activity. And that volcanic activity of the surface is kind of like our volcanic cycles here on Earth, but instead of being magma, which of course comes to the surface as liquid rock and then turns into lava, we're going to on Titan we're going to be able to see things like water ice going through a volcanic like process, which is
So
just so weird to
water
me.
is the new magma. That's what I'm hearing.
Correct. Yes. Yes.
Gotcha.
Now, in addition to that, as you already talked about, there's the rivers, lakes, streams, seas full of methane and ethane. And then within those methane and ethane lakes, uh, it's thought that there's likely an accumulation of organic matter that forms and then settles to the bottom of those lakes, creating like a sedimentary rock. So this is of interest to me, because sedimentary rock is where we find things like fossils and life here on Earth. And this particular mission probably won't be able to address that because it is a helicopter, a quadricopter. But future missions have included things like submarines, you know, um, where we might be able to, in a future mission beyond Dragonfly, start to look at these lakes, rivers, and streams in greater detail. So that's the like atmosphere, including those liquids on the surface.
Okay. So we got a whole bunch of gases going on in the upper part, right? In the atmosphere. Bunch of UV stuff going on too, some interactions and such. You get to the surface. The rock is water, and probably other. Are there other rocks there, or is it water? Frozen water is the surface.
Mostly water, and I think ammonia is the other
Okay.
component.
So you're
Um,
walking
and
on ice and ammonia.
pretty much, yes. Now, you mentioned
That's
that
cool.
it's a higher density by 4 times the density of Earth's atmosphere.
Yeah.
It's also atmospheric pressure-wise at the surface between 1.5 and 1.6 times the pressure of Earth's atmosphere, and that would be similar to being about 50 feet below the surface of water in our oceans here on Earth. So if you could swim down to 50 feet below the surface, imagine that like pressure on your head, on your ears. Um, it's pretty intense, even at the bottom of a swimming
Yeah.
pool, just a few feet down. So this would be a pretty massive change, I think. If you were somehow able
Ooh,
to
space
walk around,
tourism. Let's go there. Yeah.
right? Um, and
Well, I'll
the
tell you what,
atmosphere,
I'm not going to
because
go there. I'm not going to go there, and I'll tell you why. Last week, I dove to the bottom of the deep end of the pool at the rec center to help get my son's little toy that he dropped in there. And for a week, I had pain in my ears. It is so that 1.7, that's more than I think people realize how much pressure that really is. Like that can mess people up.
it's quite a bit.
Yeah.
Now, because the atmosphere is kind of being held on by a lot lower gravity than you would experience here on Earth, it's 370 miles in altitude is considered to be the thickness of the atmosphere, about 600 kilometers. That's about 10 times thicker than Earth's atmosphere. It's made mostly of nitrogen, about 95% nitrogen, about 5% methane, and then some other trace organic compounds like acetylene, ethane, and propane. Um, the source of the methane is currently unknown.
Hmm.
So that's interesting.
Hey, yeah.
5% of the atmosphere is methane, and we don't know how it got there.
Now you're more of a geo person. What are the options? Like I'm just thinking it either came from like it gathered there when the planet was forming, like it was seeded there, kind of like how we have water from comets, or something would have produced it. What do you think?
Well, we do know that there are clouds of methane in outer space. It's part of the, you know, abiotic, non-living processes. You can produce methane in that way, but you're also able to produce methane with life. And so, without evidence to say otherwise, we can't rule out the possibility that there's something going on there with respect to life. I mean, here on Earth, our early atmosphere was influenced quite dramatically by life, which is how we got oxygen in the atmosphere in the first place.
Right.
So to try to say that life couldn't modify an atmosphere to that level would be probably wrong, because we have quite a bit
Right.
more than 5% is oxygen, and that oxygen
Yeah.
wouldn't be there without life. So I'm not saying it is life. I'm just saying you can't rule it out.
Or maybe it could have been life. Like maybe there was life there that did that and it became so toxic it died off and nothing filled in that niche. You know? I
Well,
don't know.
maybe Dragonfly will help to understand that process a little bit better. That I'm sure
Exactly.
is one of the major goals. Now, the organic compounds, when they create these photochemical reactions, they produce a substance that is like kind of like a reddish brown, um, this haze in the atmosphere, but it also kind of rains down onto the surface, and that produces material that is kind of like a sand that creates dunes and all sorts of surface features that are very similar to dunes on Earth. And we know that there are dust storms as well that kind of go along with this. And there's only three known places in our solar system where these type of dust storms happen, and that is Earth, Mars, and now Titan.
Nice.
So that's pretty cool. A lot of unique things about Titan that are very Earth-like.
Yeah, also very Arrakis like. Have you read Dune?
No.
Oh, you got to read Dune. But it's interesting because you're talking about this stuff that kind of falls from the sky, right? Little red stuff. There's some spice in there. Anybody listening who actually read Dune will kind of hear it. But it's hot there. If we're talking about Titan, it's going to be a cold Arrakis, a cold planet that does not have much going for it. I like it.
Yep. So they said that like these actual particles are kind of they look almost like coffee grounds, we think, in terms of the texture and what they would look like in terms of their color. Um, Now, the surface itself is also very free of impact craters, and that tells us that the surface has been newly recycled and that it is a dynamic place where things are happening all the time. And as a result, it has erased the impact craters that would otherwise, pepper the surface like many of the other places, like our moon.
Right.
Now, the atmosphere does help, and it does cause some of those impactors to not hit, but there would be significant amounts of craters still from the early solar system if it were to be a like dead surface. And we see this on other moons in the solar system. Um, this is not one of those. This is a very dynamic place from what we can tell. There's no apparent crustal plates like we see in plate tectonics, but there are tectonics that are evident in that there appears to be something happening geologically underground that is causing this change to occur, and we don't fully understand that yet. And that will be part of the Dragonfly mission to include a seismograph, which will, when the quadricopter is on the surface rather than in the air, it will be looking at geologic features underground via seismology, using a seismograph and earthquake type data to study the layers of Titan in greater detail. And this is something that we've done also on Mars. We've done this on the moon. And so this is nothing new to us. And I don't see how we wouldn't be successful in that. So that should give us a little bit greater detail as to where these boundary layers, if they truly exist, would be, because that's what seismic data can do for you. It looks for these like kind of weird reflections as the sound waves, which effectively is what an earthquake wave is, as they travel through different media, as they travel through different densities of material like rock and water and or I should say liquid, as they go through these different layers, they will react differently. And we're able, as a result, to glean some information as to what their composition might be. So that's exciting that we'll have some of that data. And that will only back up some of the things that we believe to be the case as a result of some of the Cassini Huygens mission gravitational data that we were able to collect. So now, as we continue to go below the surface, the subsurface ocean you mentioned earlier is somewhere between 35 and 50 miles below the surface, and it's thought to be made of water mixed with salts and ammonia. And I came across an article where they were describing Titan's interior as cool and sluggish, and it failed to allow the interior to separate into completely differentiated layers of ice and rock. So it's kind of a mix, we think, inside. And once again, the seismic data will help clarify a lot of this.
Mm-hmm.
Now, you did
Okay.
some information on the rocket itself. We've kind of jumped around a little bit. We've talked about Titan. We've talked about some of the prior missions like Cassini Huygens. Um, let's talk a little bit more directly now about the Dragonfly mission itself.
All right. Nice. So, um, yeah, how are we going to get there, right? And then how are we going to land there when we do get there, right? Like this is all what the engineers are thinking of, right? because it's been a while, and it takes a while to get to Saturn, right? So here's what I found. What are we launching this thing on? I don't know. I really wanted to find out what could be the case, but they're not anywhere near figuring out the launch vehicle in specific quite yet. Um, I started trying to look around and see what kind of rocket it would be. My guess would be something like a Delta rocket from ULA. That seems to be similar to like what's taken up the JWST and taken other long distance ones, um, because you need enough fuel and enough thrust to get it out of Earth's gravity, right? Not just up to orbit. So you need a little bit more. But, it doesn't need a Saturn V, right? It doesn't need an
No.
SLS, but it's not going to go up on an Electron. So, and I sort of thought, hey, maybe a Falcon rocket from SpaceX. I don't know. They've
I
done.
think you'd have to be at least a Falcon Heavy to be able to have that kind of Delta V.
Yeah, yeah, and NASA. Now this would be 4 years away. The scheduled. They're looking to launch by July 2028. So that's like 5 years away. You don't know how much more SpaceX will take over, right? Because they've done astronauts to the International Space Station. That's huge. But I
I'd
don't
love
think
to see it
space.
go on a Starship,
Ooh,
but
that might be too
Starship
much.
it would likely be too much, but I'm wondering if we're going to start to see more of like a ride share type of thing where you've got multiple missions, kind of teaming up on a single rocket if they're this large and efficiencies of scale
Yeah.
once that Starship hopefully is operational. um we'll talk more about Starship in a future episode, hopefully soon, but I think that the Starship is going to be game changing to the point where it makes no sense to do anything but that.
Okay. I still feel like they're gonna have very special ones. Like we'll still have
I
a
think
lot of
this might,
selection, but
yeah, I think this mission might be a little bit premature, but given the timeline that NASA wants with their moon mission and the Starship, it should be operational by the time this thing's ready for launch. Now, as you said, it might be too much an overkill for this mission, and you're probably right. But I think, in the future that Starship like rockets will be what we end up doing for a lot.
all right, here's what I'm gonna do. I'm gonna write down our predictions right here, okay? And then we're gonna check back on this. Dave, you think that it's gonna go up on a Starship, and I think it's gonna go up on like a Delta Heavy from ULA. That's my guess. So let's see. We'll come back when it actually launches, and we'll see.
SpaceX is divesting from using their Falcon 9 and Falcon Heavy once they have Starship in place. That's my rationale for saying it's going to be Starship, because if they tap SpaceX as the launch provider, if SpaceX is where they want to be, they're not going to want to launch anything but a Starship.
Okay. But if you're not, then if it's not a Starship for whatever reason, then your backup would be a Falcon.
Falcon
Is what
Heavy.
Falcon Heavy. Okay. All right. It has been recorded. We shall see who's right. All right. So now the thing is though, like once we get it up there, once we get it going, it's going to take about 7 years to get to Saturn, right? That's a long time. Okay. But it'll be a safe time, give us enough time to, test it and all that. And it should arrive by 2034. In fact, there was an earlier launch of sometime in 2027, but there was just not too long ago some solution of funding issues. I think there was with COVID a little while back and some other political stuff. It was uncertain how much money they were going to get. So I think they've solved some of that, and so they're looking at 2028. Now, you know how space missions go. It might be a bit later, but that's the
I'm
plan as
hoping
of
that
now.
they can get it off the ground before then or at that point, because given the 7-year timeline, it would arrive mid 2030s. And part of their goal in getting it there by the mid 2030s is because Saturn And as a result, Titan will be in the same place in their seasonal cycle as it was when Cassini-Huygens was there, which
Hmm.
allows them like that continuity in their data.
Okay. Like a
So
control.
if they
It's an
don't,
extra controlled
it's a
variable.
control. Exactly.
Yeah.
Yep.
That's pretty key. I like that idea. Good thinking. So it takes 7 years to get there, right? So now how do we land, right? If you remember the 7 minutes of terror from one of the Mars rovers, I think it was Opportunity. My brain's not thinking all of them right, but it's a little bit similar to that, just a little bit. So we've got this quadcopter, right? This drone. That's what we're trying to land there, right? So we're sending it out there, and we basically have, so it's coming in 10 minutes before it hits the atmosphere. That's when the entry capsule, which has a heat shield on the front, just like you've seen in Apollo movies and all that, right? So it's got that entry capsule 10 minutes before it hits the atmosphere, they separate, right? Then what's left is basically two, well, I guess you could say three big stages, right? The first one is the aeroshell. That's that heat shield in the front. Then we've got two parachutes, and then we've got it's going to land on its own power, right? So the aeroshell, it basically protects the spacecraft for the first 6 minutes because it's coming in fast and it's going to hit that thick atmosphere and it's going to burn up like a meteor, right? So we've got that heat shield to protect it for the first 6 minutes. By the way, the whole entry, descent, and landing is 105 minutes in total. So
Wow.
first 6 minutes, it's hitting that atmosphere and it's slowing down. It's heating up, slowing down. And then it's going to get down to about Mach 1.5. And then a drogue chute's going to pop out. And for 80 minutes, it's going to have just the drogue chute and the aeroshell, the whole thing, right? 80 minutes. So most of it is actually just a parachute fall. And I think part of that too is not just to keep it safe, but also to gather data on the way down, right?
Yep.
You want to
Yep.
maximize that data that you're collecting so that you get more atmospheric data and you get a much better profile of the atmosphere. So
I
80
didn't
minutes.
think of that, but you're 100% right. I didn't think of that, but you were right. 100%.
Yeah, I mean, our first instinct is just get it on the ground
Yep.
safely and fast, right? But no, we want to use that opportunity, right?
They did the same thing during Cassini-Huygens. Huygens took forever to get to the surface, and it was
Yeah.
because of that same reason.
Mm-hmm.
They wanted to have data collection on the way down.
For about 20 minutes, you get the main chute, which is, of course, a bigger parachute. So it's going to slow it down a bit more. Then at that point, the heat shield is jettisoned. Okay. The landing skids on the actual drone, they extend. Then it starts using radar and LiDAR to sort of select where it's going to land. Now, at a height of 1.2 kilometers or 3/4 of a mile, that's when the drone gets released. And it's already going to be powered up. It's going to be, flying around, and it's going to land at, I thought this was amazing. I mean, it's becoming more reality now, but it's going to autonomously select the landing site.
Yep.
I mean, that's pretty cool. And we have to do that, right? Because it takes 70 to 90 minutes for any messages to get from them to us. So, like, we have to pre program it, much
And
like we did with the 7 minutes of terror, you know? But I just think, I don't know, something about telling something to pick a place to land, it just takes a ton of engineering, a ton of like just seeing the future. Do you know what I mean?
yes, I think it's important that you kind of come back to that 70 to 90 minutes of communication lag. And can you just kind of like go in a little bit deeper as to exactly what you mean by that for our listeners?
Yeah. So any communication from the drone can only travel as fast as the speed of light, right? So, and it takes light 70 to 90 minutes, depending on where we all are in our orbit and stuff. But, almost an hour and a half to get from Saturn to us, right? So even when you're looking at Saturn, you're seeing Saturn as it was about an hour and a half ago, right? So to think about it, if it's saying, hey, I have an issue, takes an hour and a half to get to us. And then we go, oh, we got to figure this out, however long that takes. And then we send it back. That's another hour and a half. So there's at least a 3 hour like lag time in between. So yeah, the whole process takes about as long or a little bit longer than it would take for us to get the signal. So by the time it has landed, we will not know, or actually, yeah, there's a lag there, is what I'm trying to say.
All right.
um,
So
uh, it's just I just want to say like this is just so super cool, and I forgot to mention that the part of it that the entry capsule, right before the heat shield, it's actually the rest of it's going to burn up in the atmosphere. So the thing that it was riding with when it separates, that's going to hit the atmosphere too. And it even said it was an uncontrolled fashion. I think they're just banking on that thing hitting the atmosphere, having an extreme amount of drag, and just burning up, which is kind of cool. So, but I mean, I'm super excited to land a drone on another planet. It's just super cool.
you keep calling it a drone, and I think a lot of our
I'm
listeners are
probably wrong,
thinking,
aren't I?
not necessarily. What I'm gonna point out is I think a lot of people, when you say the word drone, they think of like the drones that we see flying around that, you could go buy it, your local store, or on Amazon or something. That's not the case. This thing's the size of a VW Beetle, like an old Volkswagen Bug. It's huge, for a quadricopter. Um,
Yeah.
that is made possible by the power source that is powering this entire system, which is not solar. It is, in fact, the same device that powered the Mars Perseverance and Curiosity rovers. It is a multi mission radioisotope thermoelectric generator. So it's nuclear powered,
Ooh.
and it is still going to be having batteries on board that it's charging up so that it can have that instant power. But the power source that is, charging it back up every day is a nuclear power source.
Well, they can't use the sun, right? Because they're just so far away. Yeah.
Right. Right. And so, because of the dense atmosphere, just to kind of get into the quadricopter stuff now, we're on the surface. As I said, it was about the size of a classic Volkswagen Beetle. The atmosphere, as we have discussed, is very dense. And so that makes it flying very easy on Titan, about 38 times easier, which is quite a bit. It can do one hop per day, and those flights, those hops that it's going to be taking are going to be during the daytime, and they're going to be using them to travel approximately 10 kilometers. One Titan day is 16 Earth days.
Hmm.
So during that one day, they're going to fly about 10 kilometers. They will, over the course of the 2-year planned mission, they're expecting to see several hundred kilometers of flight distance away from the original landing site. And I found this interesting, a little fact. In one uh, of its days, it will be able to travel farther than any rover has ever traveled I'm sorry, no, in under an hour. Dragonfly can fly farther than any surface rover has ever traveled.
Oh, that's big. That is really
Yeah.
big. That is a
Yes.
huge advantage. I mean, the rovers are great. They're amazing machines. They're lasting, tens of times longer than they were supposed to. But like, if this keeps going and it's covering that much distance, we are getting amazing maps of the surface.
Right. And so it does have a number of different things that it's going to be doing while it's in the atmosphere, while it's flying. Um, the scientific instruments that are on board are going to be, of course, looking at the atmospheric and meteorological stuff as it's in flight at various different altitudes.
Mhm.
Adding to the data, of course, that you mentioned as it's entering the atmosphere, we'll be able to get reasonable data for the lower troposphere. It's going to be able to characterize geologic features from above with camera systems. But the bulk of its actual scientific work is going to be done on the surface. And the vast majority of the time, the actual craft is going to be on the surface. So it's only going to be doing these like hops to various different locations, and then from there, it's going to choose different things to study in greater detail.
So would you say this is more of a, go from place to place and get a bunch of different samples concentrating on the ground science versus the actually like mapping a surface?
I
Would you
think
say
it's
there's
quite a bit of both.
okay.
And one of the things, scouting sites of interest, they're going to be able to land at these places of interest. And one of the things I came across is they're going to try to see if they can find areas where that active volcanism is working, where the water from below is coming up and mixing with organic molecules that are already across the entirety of the surface. So now you've
Right.
got conditions where you have a known requirement for life as we know it, mixing with organic molecules like it would have been on the early Earth.
Yeah, it's one thing to go from a place that's just there and unchanging and you try to figure out the past, right? But it's another thing to actually see things changing on the surface. Like I think that's going to be where more science really gets done.
Right. Those dynamic areas of the surface are definitely of interest, I'm sure. So things that the instrumentation, as you have already discussed, can capture images. There's going to be sensors to measure things like dampness, porosity, methane, the amount of hydrogen present, meteorological equipment to measure atmospheric conditions, a seismograph, as we've already discussed, a mass spectrometer, which will analyze samples that are going to be gathered with a drill. So, once again, it's doing mostly surface activity. So, it's going to be able to drill into rocks with a pneumatic drill, and then it's going to be able to take that material that it's drilling up, send it through a mass spectrometer, and then determine what the chemical composition of the rocks are made of. And we can really do quite a bit with that, as we've seen with the Mars Curiosity rover. We were able to do quite a bit with the mass spectrometer in terms of geology, and we learned quite a bit about Mars. So I think that that particular part of the mission with the mass spectrometer, at least for me, is one of the most interesting aspects because that's where we're going to get those um, potential signatures for life that we are looking for.
Right.
Now, to kind of wrap things up, I thought it would be important to kind of see, where are we? What's the current state of the Dragonfly mission? So, as of March of 2023, the Dragonfly team got through a major design review process that's required for all NASA missions. And the location where they did this is at the John Hopkins Applied Physics Laboratory, who manages the mission. And this review process was including over 60 presentations and a panel of experts that were evaluating and assessing the mission progress. And NASA was very impressed, very happy. And, I'm really looking forward to seeing how these updates continue. One of the things I came across, I'm personally, we're from Pennsylvania. So I noticed that Penn State University was involved. Their particular involvement has to do with the actual quadricopter blade designs and things like that. One of the things they were able to do is to test the rotors in a chamber that they filled up with liquid nitrogen, um, and chilled the entire chamber to -70 Celsius.
Ooh.
And that got them close to the temperature of Titan, which is actually 50 degrees Celsius below that.
Oof.
Um,
Yikes.
Now, the biggest problem with these cold environments is that normal lubricants don't work. And so
Mm.
they are trying to figure out how to keep the quadricopter blades lubricated properly so that they can continue to function and not seize up on Titan.
Yeah, you need like a whole different material science, right? Because you're dealing with really cold temperatures, a different atmospheric pressure. I mean, that just reminds me of, back when I was taking AP physics, we were talking about, I believe it was like the pressure and temperature diagrams. And if you have just the right temperature and the right pressure, um, or even you could have room temperature, but if you have super low pressure, water turns to ice, right? Like that kind of thing where we're used to everything here on Earth because we evolved here and we've used the stuff that's here. Whole new different science, whole new materials when you're going to a different planet. That's cool.
And, this is an expensive mission. I saw some estimates that were many hundreds of millions of dollars, even up to $1 billion in some cases I was
Mm,
seeing.
wow.
And people, of course, are going to look at that and they're going to say, why? What's the point? We have so many problems here on Earth. But what they might not realize is that these are the types of things that push us to our limits. And like we just discussed, we might have to develop a brand new material, brand new lubricant that was never, there was no need for it before, but all of a sudden we now need it. And as a result, there's NASA spin-offs where we have these technologies that are, things that you didn't even fathom when these technologies first were developed, but now we need them in our everyday lives. Things like
Hmm.
GPS, things like your car's ability to stop quickly using the braking systems that are anti-lock brakes that were developed for the space shuttle so that it wouldn't go flying off the end of a normal runway. And so, these types of technologies are only made possible when you push our current technology to the absolute limits. And Titan's going to do
Yeah.
that in many ways. This mission is going to have spin-off technologies that we cannot even think of right now. And that's what science and technology does for society long term
Yes.
is we provide these technologies through the study of things that we learn about the nature of our universe and our cosmos, but as a result it also impacts our daily lives in unforeseen ways. So I'm
Right.
excited to watch this. The next phase in testing is that they're going to be putting this large Titan environment chamber in the applied physics laboratory over the next year. They're going to be doing testing in there. So that's pretty cool. And I think more to come. We're going to have to do an
Yeah.
update at some point on this. I don't know exactly when that's going to happen. But as we continue to monitor the situation that is the mission Dragonfly, we will circle back and let everybody know how things are going.
Yeah.
Um,
Now, I was looking for conspiracy things or weird memes for this mission. There's nothing for the mission, right? Nothing's really happened yet. I was looking at stuff for Titan, right? And I don't know, maybe you can tell me as more of the geophysicist. I saw a lot of them saying, "Oh, there's more oil on Titan," and then there are lots of memes with the guy propane and propane accessories. You know, um, got
King of the
blanking on the
Hill.
name right now. Yeah, King of the Hill, right? What is there truth to the idea that there's oil or petrol or not petroleum? Can't be petroleum, I don't think. But the propane, does that seem like something that's possible?
Well, I mean, propane is definitely one of the more trace things that were seen in the atmosphere. But methane is natural gas. And so absolutely there's plenty of methane. That's the vast majority of the pools
Right.
of liquid that are on the surface. So I mean there's some degree of fact there. Sure.
Hmm. Now, the other thing that I saw a lot of people saying is that if you could go on the surface of Titan, you could fly. I'm going to quiz you on this because this is what we're winding down with. What do you think? Do you think someone could fly on Titan?
Well, I actually came across something like this too, and
Oh.
supposedly the answer is yes. Now, I'm skeptical of that too, but you know, maybe it is
So
true. I'm not sure.
now it's kind of it's one of those it depends, right? Like you have to have the right stuff. So here's what I found. You have to get a really good running start, and you have to wear some sort of like wingsuit, and
Okay.
you have to run as fast as Usain Bolt.
Yeah, that's not going to happen.
No, I don't
I'm
think so. In
pretty
fact, there were
slow.
actually some people who studied this. Hannah Lerman, a 21-year-old student at the University of Leicester. It's probably Leicester. It's in the United Kingdom. They say all those things weird. They said that they had seen a lot of claims about that, and they actually looked into it. They had to factor in the density of the air, the gravity, all kinds of things with the wing. But essentially, they said you got to move about as fast. Let's see, they calculated that a person would need to run at the speed of 36 feet per second. That's 11 meters per second if you want to take a flight wearing a normal sized wingsuit with an area of about 15 square feet.
Wow.
We're saying there's a chance. Now, me, I'm thinking that we turn this into basically the Zelda Tears of the Kingdom video game, where man, you put a couple fans on something, and you get those fans going, get a little wing, and you go. You could travel. I feel like air travel would be very very efficient there, um, but that's me. I would turn it into a video game. That's the way I live life. So, but yeah, I think I'm excited to see what we learn and what we're going to learn. And it's pretty cool. We're sending a quadcopter to another moon, and it's the size of a car. How awesome is that?
I want to just point out one other thing here, that this mission is part of the New Frontiers program,
Okay.
where we're basically trying to push the limits of our ability to come up with new and creative ways to study the solar system. And it's also part of the NASA's Ocean Worlds Resources program, along with one other mission, the Europa Clipper mission, which is going to be heading to Europa, which is a moon of Jupiter that we're going to be having a discussion about in a future episode. So
Yep.
that Europa Clipper mission is exciting as well. So
Mm-hmm.
if you have yet to subscribe to the podcast, please hit that subscribe button for us. We really truly appreciate it. Uh, Please also share this out with anybody you think might be interested.